Hello good day viewers. In this tutorial we are going to provide a solution to this interesting Diophantine equation. So if you are new here, consider subscribing, press the bell icon so that you will be notified whenever I upload a new content, and don't forget to share to your learning colleagues. The equation is square root of 2 raised to the power of square root of x minus square root of 2 raised to the power of square root of y equal to 60. Before we start, you should know that a Diophantine equation is only concerned with integer solutions. Therefore, both x and y will have to be integers. And because they are under square root, we expect them to be positive. So we say that we are looking for values of x and y that are greater or equal to what? 0. Or we can say that they must be positive integers. As simple as that. Because once x is negative, the whole of this will be a complex number. And we are only interested in real numbers. All right, let's get started. According to one of the laws of indices, every square root of a number, for example, square root of a, can be expressed as a raised to the power of 1 over 2. Therefore, square root of 2 is the same thing as 2 raised to the power of what? 1 over 2. So if square root of 2 is the same thing as 2 raised to the power of 1 over 2, you know, according to one of the laws of indices, the two powers will multiply because we have another power here already. So this can be expressed as 2 raised to the power of square root of x divided by 2. This is the same thing as square root of 2 raised to the power of square root of x minus the same thing 2 raised to the power of square root of y divided by 2. And this is equal to 60. All right. Another thing you should notice here is that since this minus this equal to 60, which is a positive number, it implies that the first number here must be greater than the second number here, which also implies that x must be greater than y. Another logic we are going to apply here is that, remember, 2 divided by 2 is equal to 1. So if 2 divided by 2 is equal to 1, we can multiply both exponents by 2 divided by 2. So we have 2 raised to the power of square root of x divided by 2 multiplied by 2 divided by 2. We do the same thing for this one. 2 raised to the power of square root of y divided by 2 multiplied by 2 divided by 2, and this remains 60. This is 1, so multiplying that exponent by 1 will not change anything. Once you multiply these two together, you have 2 root x, right? So this is 2 raised to the power of 2 root x divided by 2 times 2 is 4. Do the same thing here. 2 raised to the power of 2 root y divided by 2 times 2 is 4. This remains equal to 60. Remember that law of indices which stated that a raised to the power of nm. This is equal to, it can be expressed as a to the power of n raised to the power of m, or even a raised to the power of m raised to the power of n, all the same. So I'm going to write this one as 2 raised to the power of square root of x divided by 4, but raised to the power of 2. So we have 2 raised to the power of square root of x divided by 4 raised to the power of 2. Do the same thing here. 2 raised to the power of square root of y divided by 4 to the power of 2. This is equal to 60. All right, this is nothing but difference of two squares. What can you remember? If you have a squared minus b squared, this is the same thing as a plus b multiplied by a minus b, for which this is a, this is b. So let's apply the same principle here. We have 2 raised to the power of square root of x divided by 4 plus the second one, 2 raised to the power of square root of y divided by 4 multiplied by 2 raised to the power of square root of x divided by 4 minus 2 raised to the power of square root of y divided by 4. This remains equal to 60. So now that we have two factors to the left multiplying each other and the result is 60, why not express 60 as a product of two of its factors? So let's do that. we know that this can be expressed as 60 multiplied by 1. They are the same, right? 60 times 1 is 60. Why do I write the bigger number before the smaller one? Observe that this is greater than this. They're all the same except that this is minus, this is plus, and this is minus. So the one with plus will be greater than the one with minus. So we are going to write this combination in such a way that the first one will be greater than the second one. So another one, we could have 30 multiplied by 2. This is still 60. We could have what? 20 multiplied by 3. We could have 15 multiplied by what? 4. We could have 12 multiplied by 5, right? 12 multiplied by 5. And we could have 10 multiplied by 6. All this combination will give us 60. But another observation you should make here is that just observe that the sum of these two factors is an even number. Why? This plus this, because they are like terms, right, will give us 2 of 2 raised to the power of square root of x divided by 4. Then this and this are like terms, but this is positive, this is negative. Once you add them together, you get 0. So you can see that the sum of these two will give us this. And 2 multiplied by whatever will give us an even number. Hence, we have to get a combination here that is also even. So let's observe. 60 plus 1 is 61, which is odd. This is even. This is odd. This is odd. This is odd. And this is even. So we have only 2 combinations that can give us an even number. So it implies that either the first factor is 20, the second one is 3, or the first one is 10, the second one is 6. So let us start with the first combination. Let me write it down here. 2 raised to the power of square root of x divided by 4 plus 2 raised to the power of square root of y divided by 4 equal to 30. Or the second one, 2 raised to the power of square root of x divided by 4 minus 2 raised to the power of square root of y divided by 4 equals 3. What am I doing? No, 2. It should be 2. All right. So let us solve this problem by elimination, because you can see these 2 terms are the same with negative sign and positive sign. So once you add the 2, this will be eliminated. So let us add these equations together. This plus this will give us 2 quantities, 2 of 2 to the power of square root of x divided by 4. And this will be 0, so we move to the other side. 30 plus 2 is what? 32. We can divide both sides by 2 such that 2 raised to the power of square root of x divided by 4 will be equal to 32 divided by 2 is 16. And 16 can be expressed as 2 to the power of 4. So this is 2 raised to the power of square root of x divided by 4 equal to 2 raised to the power of 4. And since the bases are the same, we equate the exponents. Right? Then square root of x will be 4 times 4 once you cross multiply. 4 times 4 is 16. And to find the value of x, you can square both sides. Square this, square that. And this will be x. And this will be 256. So we have obtained the value of x. What about the value of y? I'm going to use the same equation, but this time around, I'm going to subtract. So let me copy this. So let's subtract. Once you subtract, this will go. This minus this will be 2 quantities of 2 raised to the power of square root of y divided by 4. This is equal to this minus this would be 28. We can divide both sides by 2. So 2 raised to the power of square root of y divided by 4 is equal to 14. Or this is where the problem lies, because we cannot express 2 to any power that will give us 14. And remember, we are only concerned with integer solution. And hence, we are going to discard this condition and have to take this condition. 2 raised to the power of square root of x divided by 4 plus 2 raised to the power of square root of y divided by 4 will be equal to 10. Then 2 raised to the power of square root of x divided by 4 minus 2 raised to the power of square root of y divided by 4 will be equal to 6. Let's do the same thing. We add. Once you add this plus this will give us 2 of square root of x divided by 4. If you add this, you get 0. Move to the other side, you have 16. Oh, this is two quantities, sorry. This plus this is 2 of 2 to the power of square root of x divided by 4. We can divide both sides by 2, so that we have 2 raised to the power of square root of x divided by 4 to the left, and this is equal to 16 divided by 2 is 8. And 8 can be expressed as 2 to the power of 3. So 2 raised to the power of square root of x divided by 4 is equal to 2 raised to the power of 3. And since the bases are the same, it implies square root of x divided by 4 is equal to 3. You can multiply both sides by 4 so that square root of x is equal to 4 times 3, 12. You can square both sides in order to have the value of x. X will be 144. So this is the value of x. Let's go ahead and find the value of y. I'm going to copy this one as well. But this time around, I'm going to subtract. If you subtract, this will be 0. This will be 2 of 2 to the power of square root of y divided by 4. This minus this will give us 4. You can divide both sides by 2. 2 raised to the power of square root of y divided by 4 is equal to 4 divided by 2 is 2. And 2 is naturally to the power of 1, which implies that square root of y divided by 4 is equal to 1. Multiply both sides by 4. Square root of y is equal to 4 times 1 is 4. The square both sides, y is equal to 4 squared 16. Alright, now we have the values of x and y, but we have to plug them into the main equation to see whether we are going to get the same result to the right hand side. This is the main equation. Let me copy that. This is the main equation. Let us substitute the values of x and y. We have square root of 2 raised to the power of square root of x, which is 144, minus square root of 2 raised to the power of square root of 16. Will this give us 60? Let us evaluate. Square root of 144 is 12. And you know that square root of 2 is the same thing as 2 to the power of 1 over 2 multiplied by the square root of this, which is 12. This is minus 2 raised to the power of 1 over 2 as square root of 2. Square root of 16 is 4. Half of 12 is 6. Half of 4 is 2. This is 64. This is 4. And this is 60. Yeah. Therefore, the values of x and y are 144 and 16. And hence, this is the solution to this Diophantine equation. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.